Okay, so in all seriousness, multi-tenancy does give you a lot, but let's dig in a little deeper into what it takes to define an application. Right? So in my view, an application contains two basic parts. The first part is the runtime environment, and these are your languages, your databases, message queues. In OpenShift, all of these are provided by cartridges. The second part is your code, and these are provided by the developer, and he uses a Git repository to do this. So an application in OpenShift actually provides you with the Git repository where the developer can maintain their history, and if they ever happen to break a deployment, they can always roll back to a previous point because all of that history is available. Git also provides a distributed environment in the sense that you can have multiple developers working against the same repository. Whenever one of them is ready to do a push, they can pull down source code from the application on OpenShift, do a merge, commit their latest code, and push it. At that point, it's deployed. It's a very simple interaction model. So let's take a look at creating one of these applications and what it takes. The first thing you do is create a namespace. And a namespace is basically just a unique area for a developer to work in. He can create multiple applications within that namespace, and it allows us to make sure that those app names don't conflict with anyone else on the system. The next step is to actually define your application, and you use the rhc app create command to do this. All you have to specify really is the app name and the runtime language that the application is going to use. You have a choice of Ruby, Python, Java, Perl, and a whole bunch of others. And if for whatever reason we don't provide the language that you're looking for, you can also deploy your own language using the DIY cartridge. As soon as you've done this, the application is already online, and you can go to it in a web browser. The URL for the application is going to be your app name -the namespace.rhcloud.com. If you're using OpenShift Origin on the live CD, or if you have created your own install, it's going to be the same thing but with example.com at the end. So after the app is up, you can go and add any additional cartridges. So in this case, I'm adding MySQL. All you specify is the app name and that you wanted to add MySQL after that. So it's relatively easy to create this application, but if you wanted additional, or if you wanted to start up even faster, you can take a look at the quick starts that we provide on GitHub. And these quick starts are basically pre-configured applications. They tell you what cartridges they need. They already have everything, all of the application sources already in Git and configured to use OpenShift. So once you've created this application, you get a bunch of different resources on the system. The first one is you get a slice of the server. And what this basically is a container which limits the amount of CPU and memory that the application can utilize. Whenever you scale up or down, you get multiple instances of these containers, and the application can scale up that way. You can also SSH into any one of these containers, and you basically have shell access. You can look at everything that's going on in there. You can run PS, or if you want to debug, you can do that as well. Every application also has its own DNS name, and that's the name I showed you before with app name -namespace. But if you have your own DNS name and you have control over your own DNS server, you can associate an alias with the application and be able to access it that way. So every application also gets its own Git repository, and this is private to that application. This is different from GitHub. It has nothing to do with GitHub. It's really for that application only. And all of your developers can commit and check out code from this repository. You can also choose to add continuous integration to that application, and you do this by adding the Jenkins builder cartridge. This is just like MySQL or any other database. You just add this in and you get continuous integration. Let's take a look at how all of this works and what it takes to build a PaaS like this. So there are two major pieces to this. There is the broker and there are the nodes. The broker is the REST API front end. This is where all of the client tools, the website, and any REST API client that you build will contact to create the application, to add cartridges to it, and all of those. It also takes care of DNS for that application, and it does the application lifecycle management. It takes care of starting, stopping, scaling up, down the application. On the back end, it uses a best-of-breed scalable data store, basically Mongo, to maintain all of the metadata for this application, and uses mcollective to communicate between the broker and the node. Okay, so this picture shows you the basic pieces of OpenShift. You have the REST API on top, which is the user. The REST API talks to the broker to do all of the application lifecycle management, which is starting the app, stopping it, so on. The broker then talks to the nodes using mcollective, allocates the gear, and runs the application within the gear. The gear then is the container, and it uses a bunch of different technologies to contain the application, make sure it doesn't get out of its container. The primary one of which is SELinux. It also uses Linux control groups, kernel namespaces, and bind mounts. So each of these gears, now that they are bound using SELinux and these other technologies, you might be wondering, how do they scale? So to enable scaling between gears or within the application, we have each of the cartridges run multiple instances, one on each gear. And these cartridges can communicate between the gears by opening very specific ports. And this allows us to maintain a very secure point so that other applications cannot talk to these open ports. Having these multiple gears also allows us to load balance amongst all of them. And the way we do it in a scaled app is we have one HA proxy in front, which is the load balancer, and that then proxies all of the requests to the other gears running the website. Code deployments go against the HA proxy, and that once continuous integration passes, will then deploy it to the other gears as well. The solution we have right now is great, but it doesn't necessarily fit all the environments out there. So what we have allowed is, or what we have done is made OpenShift extremely flexible and customizable. And we do this by a couple of different things. We provide the ability for you to write your own plugins for DNS. So that way, if you don't want to use the bind DNS service that comes with OpenShift Origin, you can always create your own and plug it in. We also provide a custom auth plugin. So in OpenShift Origin, it's built on top of Mongo, but you can always extend that to have it work with LDAP or Active Directory or whatever you use in your organization. The SELinux policies bundled with Origin are pretty open, but you can always lock those down again, however you need to within your organization. There are a whole bunch of community cartridges also being built right now, and these will be available to you to use within OpenShift Origin. And we had discussed quick starts before. You can always create additional quick starts and have your developers use those quick starts to build their applications. So we spoke about gears before, and there is a similar technology built into Linux, and this is LXC, or Linux containers. We currently don't use LXC, and the reason is, even though LXC provides a great privacy and segmentation architecture, it's relatively easy to break out of it. It's elegant, but it's like these Japanese paper walls where if someone really wanted to, they could get through it. And this is why we use SE Linux. So SE Linux is a core layer of security. It was developed in association with the NSA, and it has a different way of working. It is basically, instead of in traditional Linux where it's a permissive policy, which means that it generally allows people to use stuff unless you tell it not to. SE Linux, on the other hand, is the reverse. It by default does not allow anyone to use anything unless you have a policy in there to allow that interaction to happen. So on a PaaS environment where you have many different applications running, SE Linux is a much better fit. But right now there is no combination of technologies that provides the elegance of LXC but the security of SE Linux. There is a project coming up called Secure LXC, which basically combines the two and provides this, but it's not really out there right now. So our present looks a bit ugly, and it looks like this jumble of wires over here, where you have many different technologies that you have to piece together to work properly. But this is already built into OpenShift. So OpenShift Origin really is a tool for you to use within your development and ops environments, and we are hoping that it is a tool that you will extend to work within your organization and contribute code back to us so that we can keep making it a better project. Next, I'm going to walk you through what we have on our ISO. It's basically a standalone version of OpenShift Origin. It runs on a RAM disk, and you can boot it up in VMware or VirtualBox, any other virtualization environment that you would like. So I'm going to be using VirtualBox to demo this. And the first thing you would do is create a new virtual machine. And let's call this Origin. We use a 64-bit Fedora base to build this on. As far as memory goes, you want to give it at least 2 gigs of RAM. It runs on a RAM disk, so if you don't give it enough RAM, it will run out of space and then hang. 2 gigs gives you enough space for about 2 applications to run. The more memory you give, the better it is. And if you plan to run this on your own hardware, it's even better if you can install it onto the hard drive itself. So since it's running on a RAM disk, we don't need a hard drive, so I'll skip that step and create the VM. So once it starts, we will select the OpenShift Origin ISO. Start the virtual machine. So this takes a couple of seconds to start up, and in the background it's spinning up bind for DNS, it's spinning up Mongo for authentication, as well as the application metadata storage. It's spinning up mcollective. Both the broker and node are sitting within the same VM and it is standalone. So it's spinning up mcollective to talk between those two components. And to allow you to easily test out this CD, it's running Fedora, and it's going to bring up a graphical environment. That's completely optional. When you are building your own system, you don't actually need to have a GNOME or anything else running there. It's also going to bring up a dialog over here saying that I don't have OpenGL turned on. You can skip that. It's just a facility that VirtualBox doesn't provide. Okay, so we have we have our VM up and running. And when this VM first starts up, you already have a user created. The user's name is admin, and the password you can use with it is admin. So as I had said before, the first step is to create a namespace. You do this using the rhc domain create command. I'll call it my namespace, and it's going to ask me to create an SSH key. And this is basically to make the Git interaction a lot simpler. You don't have to specify a password each time. Okay, now that's up and running. The next step is to create an application, and I'm going to create a WordPress application using the quick start. So let's do that. WordPress runs on PHP 5, so I selected that as the application type. So once it's finished creating the application, it registers that namespace with bind. This is running all within this virtual machine, so you cannot access it from outside. We'll create a web browser within the VM to actually see it. So as soon as the application is created, you can go to it in Firefox, and you get this basic template of that application, which tells you what other steps you can do to push a code. So let's do a quick code push. We'll go into the WordPress PHP directory and edit the index PHP, and I'll replace the whole thing with just a call to PHP info. Commit our code, do a git push, and refresh the page. And that's it. That's as simple as the deployment is. All you have to do is commit, push, and your code is up there. Okay, so let's take a look at using one of the quick starts, and I'll go to GitHub/OpenShift. And under here, we have all of our repositories. Let's search for WordPress, and we'll use the WordPress example quick start. Each quick start comes with a set of instructions that you can follow. I've already created the application, so I'm going to create or add MySQL to it next. Okay, so MySQL is added. Let's then go ahead and pull down code from the GitHub repository into the local repository. So the first step over there adds the GitHub repository as an upstream, and the second one pulls down the code and merges it with your local repository. Once that is done, we will do a git push, and that deploys this code to your application. As part of the quick start, you also get a bunch of hooks that you can write so that you can register your own steps against the application lifecycle. So in this WordPress quick start, we actually have a build and deploy hook which installs the WordPress database schema into the application. Now that that's done, we can go back and do a quick refresh, and we have WordPress up and running. Okay. Next steps for you all to do is basically you can go ahead and download the live CD, try it out, run it in a virtual machine, install it on your hard drive. And if you have any questions, feel free to find us on the forums. We have a mailing list for you to email all the developers on the project, and they will reply back to you. And you can also find us on IRC. We are on Freenode at #OpenShift-dev.